Hello all. Today we are excited to share a project with you. We'll be discussing how we analyze YouTube comments to understand political perspectives and public sentiment. We'll introduce a generative question answering system that helps answer user queries about public opinions. Why YouTube comments? Because they are a goldmine of insights into public opinion, reflecting a wide spectrum of emotions, concerns, and viewpoints which often remain unnoticed. People tend to watch videos, scroll through the comments, and get lost among irrelevant ones without noticing the actual genuine opinions of the video content. Analyzing these comments enables us to predict shifts in public sentiment, providing pivotal data driven insights for political strategists, policymakers, media analysts, and the general public. We are focusing on the official YouTube channels of Canadian political figures Justin Trudeau, the Prime Minister of Canada, and Pierre Poilievre, the leader of the official opposition. Some challenges we navigated through this were handling large data volumes of unstructured text of different languages and noise in the content like spam and irrelevant comments. We have created a script which takes in YouTube API key and channel IDs, extracts the video IDs from the given channels, and then proceeds to collect the comments from these videos. We then pre-process them, which involve translating French comments into English, extracting topic discussed, performing sentiment analysis, and so on. Then we implement a retrieval augmented generation model. We are dividing the whole corpus of processed data into smaller chunks and feeding it to the text embedding model, which converts it into a high dimensional space where each word is represented as a word embedding. Once the embeddings are created, they are stored and managed in Pinecone DB, which is a vector database. The green flow in the diagram illustrates a user question which the model converts into embeddings. By comparing the cosine similarity between the user query and the relevant comments stored in the DB, we identified the top comments with the highest cosine similarity scores. These comments are subsequently used along with enhanced prompts for the LLM, resulting in a more suitable answer. You may think, why an LLM? Why not an LLM? Why a RAG model? Well, LLMs can hallucinate by generating content that sounds plausible but isn't grounded in real data. During the pre-training phase, these models leverage a broad knowledge base. However, their response may diverge from the specific data they encounter, as their understanding is limited to the data provided during the training phase. Whereas a RAG model takes a more data-centric approach. It uses a retrieval mechanism by utilizing embeddings stored in Pinecone. It directly references the relevant comments when responding to the queries. This ensures that the output is not only relevant but also accurate to the input, minimizing the chance of irrelevant or incorrect information. So far, we have put together the scraping of data, pre-processing them, and EDA on the two channels data. We are now testing the feasibility of the entire pipeline with a small chunk of a prepared dataset. In the upcoming days, we will be focusing on UI development, creating data chunks, embeddings, loading data into the vector DB, implementing cosine similarity search, and argument prompt to get responses. We have encountered challenges like API limitations along with data quality issues. Our mitigation strategies for these issues include testing the whole pipeline with a smaller dataset, implementing batch processing to manage data efficiently, and adopting a modular design for UI development to ensure smooth integration. We'll meet you next time with an answering bot on public opinion about political parties. Who knows? Maybe we'll even predict the outcome of the next election. Thank you.